Welcome to Zero Knowledge, a podcast where we talk about the latest in zero-knowledge research and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
This week, we chat with Henry de Valence from the Zcash Foundation. We talk about crypto libraries, the work he's doing at the foundation, the goals of the Zebra Zcash implementation, and the TCN Coalition, a group he is working with that aims to build and evaluate privacy-preserving contact tracing protocols. But before we start in, I want to say thank you to this week's sponsor, Trail of Bits. In their most recent blog post, Trail of Bits announced some important updates to Echidna, their smart contract fuzzer. Echidna is one of the tools that the team of Trail of Bits used the most in their smart contract audits. In fact, it has been used in almost 35% of these audits over the last 2 years. This includes the audits they did for MakerDAO, 0x, and Balancer. In this recent update to the fuzzer, they have streamlined integrations with complex truffle projects, and the tool now supports smart contracts written in Viper. They have also removed the need for Echidna-specific tests and can automatically fuzz assert statements in Solidity. For more about all of these new features, check out their blog post, which I've added in the show notes, or visit trailofbits.com for more about their tools and services. So thank you again, Trail of Bits. And now here's our interview with Henry. So today, I want to welcome Henry de Valence, who is a cryptographic researcher at Zcash Foundation, to the show. Welcome to the show, Henry.
Hi, nice to be here.
Glad to have you.
Today, our plan is to talk, mostly about the work you do at the Zcash Foundation, but we also want to talk about this project that you're involved in called TCN, which is a contact tracing project, which I think is very relevant today. I think a good starting point for this episode is to find out a little bit more about you. Tell us a little bit about your start in cryptography and how that led you to the Zcash Foundation.
So previously to doing cryptography, I had studied mathematics, and I was very interested in algebraic geometry and number theory. At the same time, interested in doing computer programming, and also interested in, how people interact with each other in a broad sense of, in a kind of political sense, that it's like a broad understanding of politics, right? Coincidentally, the intersection of all of those three things includes cryptography, or rather cryptography has some bit of each of those. And so that's sort of what was the motivating factor for me. And at the time, I guess this would have been like maybe 1 year after the Snowden revelations. So that was kind of the context at the time.
Were you also working in security at any point, or was it always straight into cryptography?
No, I was doing academic math, and then I switched to doing academic cryptography. So I started a PhD in cryptography, and then that didn't really work out, so I quit and ended up in San Francisco, did some cryptography implementation work, and then I ended up at Chain.
Oh, wait, was Oleg from...
Yes.
Oleg,
yes.
Because he's been on the show and he mentioned the Chain team. Okay.
Yes. So Oleg Andreev and Kathy Yun and we worked at Chain on doing bulletproofs.
Cool.
And then last year I moved to the Zcash Foundation, where I am now.
And the Zcash Foundation originally, I don't think it was originally built up of cryptographers. I feel like it was more of this kind of foundation, management team. At least that's how I understood it. Has it always had a cryptography team? Or were you kind of an early hire for that?
So the foundation started pretty small. And in the last year, one of the goals of the strategic goals of the Zcash Foundation has been to build out an engineering team in order to kind of practically decentralize the development of Zcash. And so I was part of that effort.
Cool.
I think, me being Snowden and Rust World perhaps, but I mostly know you, or before you joined the Zcash Foundation, and I got to know you more like through talks and whatever else. I mostly know you just from the Dalek libraries. How did those come into existence, and why did you start making crypto libraries in Rust?
At the time, I was working on a project, and we needed a cryptography implementation, and the existing libraries weren't great.
Weren't great or non-existent?
I don't know, like if you consider sort of like trying to do FFI to OpenSSL to be something that exists.
And somewhat existent.
At a kind of practical level of like, is there some library that you can use as a kind of like mid-level tooling to build cryptography implementations? I don't think that really existed at the time. One problem with cryptography libraries that to me seems to come out of a place of kind of like fear of rolling your own crypto is that unlike other problem domains where there are various different kind of levels of abstraction complexity that people can hop in and out of, if your problem doesn't cleanly fit into one or the other, then you can kind of jump up or down a layer of abstraction. In cryptography libraries, the impulse to kind of like no one should roll their own crypto leads to people building very brittle and inflexible APIs that are designed for like, only application developers who want to like use crypto will use this interface. And everyone else is assumed to be like an expert crypto implementer who, doesn't need reusable tools. But the problem is that doesn't actually work because there's no clear kind of like bright red line between using crypto and doing crypto. And it also doesn't really scale to have more complex kinds of cryptography. As you do cryptographic engineering for kind of simple crypto problems, like, I don't know, doing a key exchange or doing a signature, there's all kinds of subtle things that come up and they have to be engineered away. But the level of cryptographic complexity to kind of engineer a system around for something like Zcash is just like orders of magnitude more. And so if your goal is we want to kind of like scale up the kinds of complexity of cryptography that are actually practical to deploy, then you have to kind of take this sort of like monolith of a crypto implementation, and you have to kind of finally segment all of the internal parts to each be their own sort of like different layers that build on each other. And rather than just saying like, we'll have this like safe interface for the like users of this thing, and then internally it will do, whatever kind of stuff because only experts look at the internals. You actually have to sort of take that same design perspective and put it at every sort of finer level of abstraction internally as well.
Is that a little bit about, like, I wonder if this is similar at all to what's happened with the ZK snark breakdown and how there's certain parts of it now that are being tackled, like snark as this general construction and this focus on like the parts that Plonk and Marlin deal with or something, like, whereas originally you would have had to construct these entire things completely. Now you see them sort of breaking them down. Does that fall into that category of what you're describing?
I mean, I feel like that's the same kind of process, but rather than being applied to kind of software implementation.
It's, more hardcore level than just like engineering level, like how to do cryptography in a good way versus how to do programming in a good way.
Yeah, I mean, to me, it feels like actually a very similar process because it's saying, here's this like big thing, right? And that thing might be software or it might be some kind of conceptual machinery. And then it's like, actually, what is the correct way to decompose this complex thing into simpler pieces that fit together? And then once you've done that, what are all the ways that you can arrange those like blocks? And how can you understand these other 12 things as being different combinations of these same sort of like blocks.
So when you going back to that library that you rewrote or you wrote, did you think about that differently? Like, how did you use that structure that you just defined in your creation of that library or those libraries? Is it one or many?
There's a whole set.
Okay.
I'm only responsible for some of the parts. So there's like basically primitives for doing constant time operations. One of the libraries, and then there's an implementation of Ristretto and Curve 25519. And then there's the bulletproofs library that I mentioned earlier, which is kind of like assembling these pieces.
Cool.
Did you invent the Ristretto stuff or did you implement it?
So Ristretto was invented by Mike Hamburg, but I was working to implement and like write up notes on it. Mike published a paper about decaf, which is the kind of like core idea of that construction. And in the paper, there's a description of, there's like 2 paragraphs towards the end of the paper that say, here's how you can do this for Curve 25519. Because unfortunately, the design of the curve throws some extra wrenches in the machinery. There's different ways that you could follow the notes in that paper to come up with a construction. So Ristretto is like, here's the kind of like canonical way to apply this technique to Curve 25519. So the ideas were not mine. I just did a lot of the notes.
I'm probably jumping ahead of the audience here a little bit because we are users of SR 25519. But maybe just before we jump into more Zcash Foundation stuff and get back on track, what's the difference between ED 25519, which people are probably familiar with, and SR?
So ED 25519 is a signature scheme that uses the Edwards form of Curve 25519. SR 255 is a signature scheme constructed in mostly the same way that uses Ristretto instead of the Curve 25519 directly.
What's the difference between normal 25519, curve operations group work, and like what does Ristretto bring to the table, kind of?
So maybe an alternate form of the question is like, what is the advantage of Ristretto, or what does it give you?
Yeah.
That, I guess, ties back into the discussion of having kind of like mid-level interfaces, whether those are kind of software interfaces or conceptual interfaces. And in fact, actually, those two things, should also be aligned in order to reduce the chance that the software has bugs. But basically, the problem is, suppose you are a cryptographer or a crypto implementer or whatever, and someone has put out some new crypto protocol, and you think, wow, this is, the flubar protocol is the coolest thing ever, and I want to like implement and deploy it immediately. And you open up this paper that someone put on ePrint, and the like first sentence of the paper is like, okay, let G be a group of prime order P. And when you want to instantiate this protocol, you know that you're probably going to want to try to provide that group functionality using an elliptic curve. But the problem is that most of the available elliptic curve parameters don't actually give you the abstraction that the paper is going to conceptually expect, at least without some kind of like significant caveats. So with NIST P256, for example, the implementation might have formulas that execute in constant time, or it might not. Historically, people have not had what are called unified formulas for the NIST curves. What that means is a formula that is valid regardless of what input elements you put in. So if you have something that is sort of one formula, then that's very easy to implement in constant time. If the formula has some kind of condition, like, oh, if you're doing this special operation and you do these other things, that's much harder to implement. And so it's much more likely that there are implementation problems. To some extent, this is better now. Or you could say, oh, I'm going to use like curve 25519 because that's a very well-known elliptic curve and many people seem to like it. But the problem that you'll have there is that it doesn't actually give you a group of prime order. That curve has a small cofactor, so meaning that the order of the entire group is not a prime number, but it's a prime number with sort of one big prime factor plus this small cofactor. And in curve 25519's case, that's 8. And now you have this very subtle kind of abstraction mismatch between, on the one hand, what the expectations of the crypto protocol are, and on the other hand, what the thing that you are using to instantiate it actually does. This can have implications that sort of range from being very like fatal showstopper bugs on the one hand to having like very subtle downstream effects that you don't necessarily notice at first, but that will cause interesting problems later on. So an example of the first kind of class of problems with cofactors is there was a bug in Monero a few years ago that was not exploited, but effectively the cofactor of 8 in the curve that they were using to implement that version of the CryptoNote protocol translated into someone could spend a note 8 times by making sort of like 7 other sort of related copies of the note.
Wow.
Which is obviously quite bad for a cryptocurrency. And that's a kind of like example of a pretty fatal vulnerability, although to my knowledge, it was not exploited. And on the other hand, even with something kind of as quote, simple as ED 25519 signatures, the cofactor 8 causes a bunch of very subtle and annoying properties downstream. So for instance, the RFC that specifies ED 25519 signatures does not actually require all conformant implementations to agree on like what signatures are valid. And you could imagine that, for instance, if you like use ED 25519 in an application that requires like consensus, then agreeing on like whether or not signatures are valid or not is kind of important. And this sort of through twists and turns ultimately comes out of this cofactor issue. And it also means that doing things like through sort of different twists and turns, doing like hierarchical key derivation is much more complicated and difficult. You can even have protocols where everything seems fine, but actually sort of the effects of this cofactor problem bubble all the way up into the user interface. So in an early version of the one of the Tor hidden service protocols, this was fixed in the design phase. There was a problem where the 8 in the order of the group translated into, you could actually have 8 different addresses for the same onion service, which is kind of a surprising behavior.
And this is what Ristretto actually fixes for, I guess.
Yeah. So if you use Ristretto, then all of these problems are kind of like handled for you. You get like an encoding function and a decoding function, and it does all the validation kind of all bundled in, and it sort of does what you expect.
Cool.
Has it had its own share of like, does it have new issues or other things that it causes?
Not that I'm aware of. I think it seems to work pretty well, but I'm a little bit biased. So actually, the bulletproofs example is a really good example of how this played out. When I was at Chain, we used Ristretto to implement the bulletproofs zero knowledge proof system. First to do the sort of simpler range proof part, of that protocol. And second, to do the kind of arbitrary circuit proof stuff, actually using some kind of like custom extensions to the protocol. That was kind of a very good test case of like, okay, you have this abstraction. Is it actually useful for building things? And it turned out, yes, we kind of were able to ignore all of the sort of lower level details and just treat this thing as like, oh, you've got this group and it can do group operations. And we ended up with what I think is a very high quality and also very high performance implementation. It's the fastest bulletproofs implementation that I know of. And I think actually it's now going to be used by MobileCoin, although I don't know anything else about it other than it showed up in their cargo.toml.
All right, so I guess let's turn our eyes towards Zcash Foundation, and maybe let's start out just simply, what is your role there?
So I am a cryptographic researcher at the Zcash Foundation, and what does that actually mean? It means that I do some amount of research and some amount of engineering and some amount of researchy engineering, depending on sort of what needs to be done. As a small team, you kind of have to sort of jump between things. In the earlier part of last year, I was doing some research on a zero-knowledge proof compiler for Schnorr proofs. So rather than the kind of like full-scale complexity of arithmetic circuits, you can also do quite a lot just with Schnorr proofs, but which are just statements about group elements and how they're related by discrete logarithms. Like I know the discrete logarithm of this group element with respect to this other one, but implementing them is kind of tedious. And so I wrote a library that has a sort of a toolkit for doing Schnorr proofs, and then also it actually implements a proof compiler in Rust macros that lets you write a proof statement using similar notation to what you would find in an academic paper, and it just generates the entire implementation for you. So you can sort of read through a paper and, with the paper in one window and your text editor in the other window, you can write out a proof statement that looks almost identical to what's in the paper, and it will automatically generate a sort of production quality implementation of that proof statement.
Wow. That's so useful.
Yeah.
That was an early project that you worked on.
And then we started building an engineering team and starting our project to have the Zcash Foundation have a independently developed Zcash node, which is Zebra.
Yeah, and Zebra originally Parity built that sort of first version of it. Mm-hmm. So I guess you were very involved in that handover. Mm-hmm. Frederick, maybe do you want to share a little bit about what Zebra was from the Parity side at the start?
Sure. I don't know. I think we handed it over before you joined the foundation, Henry, but from Parity's end, we had built a Bitcoin client already. And the original Zcash client is based on the C++ Bitcoin client. And then they've added more and more, like originally it was just some tweaks on a fork, and then they added more and more stuff. And then they had their own crypto library that was all written in Rust, and they sort of, plugged that in. And once it got to that point, it was actually pretty trivial for us to plug in that Rust library into our Rust implementation of Bitcoin. And so that's sort of where this originally came from, where we were contracted by the Zcash Foundation to build a Rust Zcash implementation based on our Bitcoin code.
Because the original Zcash implementation is written in C++?
Yeah. But now, because of how the company's moved, it's like half C++, half Rust, kind of FFI'd monster that is really hard to deal with. And then, when we were done, it was syncing mainnet and it was doing its job. We handed it over. The only one that was really around that I talked to was Deirdre, and George. He was like just joining as we were handing this off, and then I had a sync up a few months after that, and they'd taken it on. They grokked the code base a bit and started working on it. But I don't really know where it's gone from there.
So with Zcash D, the situation is as was just described, right? You've got this kind of like Rust implementation of very high sophistication and complexity cryptography, and then it's sort of like bolted on to the side of this Bitcoin code base. And I don't follow Bitcoin super closely, but my understanding is that since Zcash was started, the quality of the Bitcoin code base has improved considerably, but not all of those changes have sort of landed because Zcash forked too early. So you have a situation where you have this kind of like very precisely engineered, like, you know, sort of like beautiful V8 engine that's just kind of like bolted onto the side of this clanking machinery.
And you just called it Zcash D. So Zcash D, I think we have covered this before on the show, but Zcash D is the original client. That version of it was basically created and is now maintained by the ECC, the Electric Coin Company. One of the questions that I have had kind of, and I was hoping you could help us coming on the show, is a little bit about like, how do you work with the ECC? Do you work with the ECC? Like, you have your own client implementation now. So like, do you share things? Like, how is the communication between you?
I would say that at an engineering level, there's very good communication. When we have questions or concerns about things in the Zcash spec or about some of the various common libraries that we share, you know, we have very good engineering communication. In terms of kind of the like strategic priorities, it's totally independent.
Got it.
And actually, so one of the things that has been really beneficial from us working on this second client is that we've been going, because we have been doing this implementation based on the Zcash protocol specification, it gives us a really good way to kind of spot any inconsistencies or bugs in the spec or bugs in the implementation, because we have to kind of go through things with a very fine-toothed comb. Wow,
yeah. It's almost like, it sounds like a verification of sorts, like you're going step by step through like an audit, even though I guess you're recreating it.
Yeah, I would say that the process is quite similar in that respect.
Let's go back to Zebra. So I want to hear a little bit more about what you are doing on Zebra now. So we've outlined this differentiation between these two clients, and you still work with them on the engineering side to stay, I guess, synced. But where is the project at? So
we're part of the way through. We have a slightly different goal. It's overlapping, but I would say that it's slightly different. With Zcash D, right, the goal of that software is it's supposed to be a node implementation, right? But there are a lot of things that you might want to do that aren't just sort of being a node implementation, all kinds of sort of like tooling for things that aren't necessarily literally a full node, or maybe they need to be a full node as part of doing something else, but really what they want is tooling for interacting with the Zcash chain. And so our kind of development process is that we are basically building a set of tools and libraries for working with the Zcash chain. Also, as you know, a very convenient side effect, if you assemble those together, then you get a full node. But our focus is on having that kind of come as a collection of building blocks. And so we're making pretty good progress on having all of those blocks complete. Last fall, we wrote a completely new network stack for Zcash that allows, basically, we have this library called Zebra Network. And although it's still unstable, you know, in the future, if you have an application that wants to interact with the Zcash network in some way, you can import this library and call init, and all of the kind of node network layer machinery gets spun up for you automatically, and has a connection pool and sort of does all that stuff. We have also been working on a library for sort of modeling all of the different data structures that are used in Zcash. So as a kind of result of the historical development of Zcash, Zcash transactions have 4 different formats that are all quite different, right? There's sort of like the classic Bitcoin transactions, and then there are the Sprout transactions. There's also sampling transactions, because after getting the initial prototype done, they moved from the original zero-knowledge proof system, which was using BCTD 14 proofs, codenamed Sprout, to a much, much better implementation using a different proof system, codenamed Sapling. There's sort of all these different versions, and we're taking a sort of very kind of like functional programming type approach to modeling these things. So we actually defined a data model for Zcash transactions that makes all of rather than letting you sort of have all these different pieces of data that might or might not be valid in combination with each other, we use enums and careful sort of modeling of all of these components to make sure that it's actually impossible to ever construct a transaction object using this library that doesn't correspond to a kind of sort of structurally valid Zcash transaction. And in the process of doing that, we've identified a couple of sort of small bugs in the spec, which has been a good experience.
I wonder if it's not proving that kind of idea that having 2 clients makes for a safer, more secure network. 2 or more, let's say. Just having at least 2 teams, maybe more teams, potentially really solves for a lot of the vulnerability. Like, it basically would mean that vulnerabilities would be found faster, easier.
Yeah, I don't know that it would sort of solve everything, but I think that it can definitely like cut out like a particular class of bugs. It's relatively easier to write a specification that reads as if it is very precise. But the actual test of a specification is like, can you implement it? Because that requires working through sort of every tiny detail, it's very difficult to check that without sort of actually doing it.
I'm just curious what the size of, the engineering team at the Foundation is now, because as I said earlier, when we handed this off, it was 1 or 2 people. I assume it's larger now. And, where is the team headed?
So at the moment, the engineering team at the Foundation is sort of 3.5 people. There's myself, there's Deirdre Connolly, who's our core engineer. There's George Tankersley, who's the director of engineering. And we have some of Chelsea Conlow's time, and the rest of her time is spent on her PhD work.
So yeah, it's still a pretty lean team then.
Yes.
I mean, I like the approach. Just talking about the networking stack as an example, this is something that's come up in Ethereum tons of times, where someone wants to write a network crawler or something just to figure out how many nodes are online or whatever. And they, like, both the Open Ethereum implementation in Rust and the Go implementation are written in such a way that you can't really pull out networking and use it on its own. So anyone who wants to write a crawler has to rewrite the networking stack from scratch.
So it's interesting that you bring that up as an example, because that was actually kind of what we had done too. So one of the kind of small but important pieces of Zcash infrastructure is what's called a DNS Cedar, which is a service that basically crawls the network, and then it lets you make a DNS lookup, and then it will hand you some peers that you can sort of bootstrap your way into the network. When we were trying to figure out what direction we wanted to take Zebra in, we were trying to figure out whether we could sort of, along the way, when the original Parity Bitcoin codebase was made, the whole like Rust async networking ecosystem also advanced by like several light years. So we were trying, right? So all this like async await stuff is now built into the language. And so we were trying to figure out, would it be possible to kind of like jump directly to like the latest version of async Rust and also have this kind of library first architecture? And our MVP to kind of figure out is that realistic, and like could we do a small project to sort of de-risk that design, was actually to make a crawler that could serve as the backend for this DNS Cedar. And so this exact problem that I guess other people also have is perfectly solved by the way that we've redesigned the Zebra architecture.
Yeah.
So sort of to change course, but stay within the Zcash Foundation topic, I was wondering if your work there, if you're touching on cross-chain privacy research, because I've sort of heard through the grapevine that you were doing something around that. And I was curious to hear a little bit more about it. Well, or whatever you feel like sharing. I don't know.
Yeah, so actually we were planning to publish some stuff about that this week, actually. So I'll just sort of tell you about things that we've been working on.
Oh, cool.
We previously put in our, in fact, all of the engineering work that the Zcash Foundation does is part of a public roadmap because we're supposed to be transparent and accountable. And so we said that we were going to work on the design of a Zcash to Cosmos peg zone. And after publishing some kind of like very basic initial notes and then going around to try to talk to a bunch of Cosmos people, we have a kind of sort of second iteration of that design that we're planning to publish a description of real soon.
What would it mean though? Like if you like the Zcash chain with the shielded accounts live in one place.
Yeah.
Would it be like a bridge to another chain? Like I'm confused actually about what that what that means in this context. What would it look like? So
in Cosmos specifically, they have a whole kind of cross-chain system called IBC, which stands for inter-blockchain communication, and that's kind of like built into like what Cosmos is.
Yeah.
Basically, you're gonna lock up funds on one chain and then transfer kind of a bearer token for those locked up funds to the second chain. But what that requires is that the two different chains or zones, as the Cosmos people call them, both have transaction finality, which for Cosmos, which is a proof of stake system, kind of comes naturally. But in any proof of work system, you don't ever actually get finality for like, did this transaction happen? All you get is, how many confirmations have happened, how many blocks have been mined since this transaction happened. And that gives you kind of a probabilistic finality where after a certain number of confirmations, you can say, okay, the probability that there's some like alternate chain going to happen is so low that I don't really care. But that doesn't quite work with this IBC design. So instead, in Cosmos, for doing interoperability with proof of work chains, they have what's called a peg zone mechanism, where essentially in the sort of Cosmos universe, you have this standardized cross-chain thing, and there's a special zone that then sort of takes the responsibility to decide when some transactions have happened on the proof of work chain. And what we've been working on is actually how to make a Cosmos peg zone that can hold funds
like in a shielded way, or like the private version way. Yeah.
Yes.
Because that's like the regular pegging from other chains is probably, there's probably a system to do that, but the kind of the unique thing about the Zcash build is that there's this shielded account, private transaction.
Right. And the really cool thing about this is if we can get it right, I'm just going to hedge that a little bit because it's still a work in progress. But if we can get it right, then we can actually combine like the coolest feature of Zcash with what to me is the coolest feature of Cosmos, which is this sort of interoperability. And to me, the coolest feature of Zcash is that unlike all of the other cryptocurrency privacy solutions, Zcash has very, very strong network effects for privacy. And the way that works is there's only one shielded pool, right? So new users gain anonymity from all prior transactions of all existing users, and in turn contribute to greater anonymity for the whole system. And so if we can build basically a shielded cross-chain that allows you to sort of bridge not the sort of transparent universes, but bridge sort of the inside of a shielded pool to the inside of another shielded pool, you can sort of broaden those network effects for privacy and anonymity to also include other chains.
Frederick, is there also a way to peg from outside into Polkadot?
Yeah. It's the same thing.
It's a similar thing. So if you crack this, Henry, you might be able to use it in a few different places, I guess.
Yeah.
I think in any sort of bridged solution, it's the same thing, yeah. So
I'm not sure that there's really anything that's like super Cosmos specific about this. It's just sort of what we picked as our current sort of target.
Cool. That's exciting. I mean, that idea of sort of cross-chain privacy has been at least something that's come up a couple times here. But like, who would implement it, and like, how close do you think you are?
So at the moment, we're working on scoping out the design, and in particular, trying to break all of so we have this sort of, final beautiful goal of the dream world, and breaking down, okay, here are all the steps that would be required to get there. And of all of these different components that are required for this end thing, what are the ways that we can sort of assemble subsets of those to have like useful intermediate products along the way to building sort of this final thing? We have a kind of a two-phase design where the first phase is just going to be like a basic peg zone that is set up to enable all of the features that we want in the second phase, where we would add a shielding into the peg mechanism itself.
And would you build it yourself? This is like a Zcash Foundation build, or is it combined with other teams?
So we're working on a plan to build it. We probably would not do all of it ourselves, but we're kind of in discussions with various people
to see. Interesting. Yeah. This is a very exciting part of like Zcash to me has been in a way like the champion of zero knowledge proofs and the education and this amazing like interesting ecosystem, but still sort of standing alone, like because it can't interface with a lot of these other things. So I'd be so curious to see what it looks like once it starts connecting up to other networks. That's really cool.
I'm very excited.
So now we've covered a lot about your work before Zcash and during Zcash, and now I want to kind of go forward because I know that you've been involved in another project, a contact tracing project. So maybe we can find out a little bit about what you're working on there.
Yeah, so there's a few different projects for doing privacy-preserving contact tracing. I'm involved with one of them called the TCN Coalition. TCN stands for Temporary Contact Number, which is the term for the numbers that are broadcast over Bluetooth. All of these systems are kind of supplemental contact tracing, or maybe it's better even to call them just contact notification technologies.
Should we define what that is? Like, what is contact tracing? What is contact notification?
I think so, because it's also a thing that I really struggle with imagining what it actually does. Like, what does it bring to the table? How does it help with anything? Yeah. That's sort of still, like I see a bunch of people talking about contact tracing, and bunch of companies started working on it, rolling out solutions, and I'm kind of sitting here going, what's the problem? What is it solving?
So the basic idea of contact tracing is like, okay, you've got some kind of infectious disease and it spreads from person to person. And so when someone turns out to have contracted this disease, to slow or prevent the spread, you should find out as best as possible all the people who they could have come in contact with and try to sort of do something, whether that's test them or ask them to isolate or whatever.
And so far, it's been done manually, basically. Like when somebody got sick, you hear about it. Like I remember when the first case happened in Germany, like they were able to trace, all the people that this person had come into contact with, but not because of an app or because of an algorithm.
Right. This is like a totally like classical technique of public health. It's not like a new idea. What is the new suggestion is that now that people carry around devices that have little Bluetooth radios in them, maybe it's possible to provide an automated technology that can either supplement the sort of traditional methods or act as a kind of a backstop in the event that they don't work for whatever reason.
So it sort of hinges on some action being taken. I think that's where it breaks down for me, because I always see the context of these applications being talked about as gathering data. It's just gathering data for analysis. It's not that I then tell someone that they've been in touch with someone and should go get tested or whatever it might be. So, I guess that's where mentally it breaks down for me. I mean, it's obviously a controversial topic because of this, because everyone is just talking about tracking and taking a bunch of data. And I guess that's in part what you're trying to address with these projects, is actually doing it in a privacy-preserving way.
Yeah, so there's a number of different projects that all have the kind of common goal of demonstrating that, in fact, this sort of data collection that you're talking about is not necessary. It's not necessary to track everyone's whereabouts if you can just be able to determine who someone's potential contacts are. And I would also kind of stress that this is something that is one tool among other tools. There's a lot of problems where a kind of technical solution can be very useful and is worthwhile to try to develop, but is not by itself sufficient to solve the entire problem. However, the people who have skills relevant to designing sort of privacy-preserving crypto protocols are not going to be able to usefully apply those skills to like any other aspect of this crisis. Like someone can't just sort of like pivot to be like, oh, I'm a biomedical expert and I can design new tests or something, right?
Although Twitter, crypto Twitter makes us think otherwise, but yeah. Sorry.
So the reason that I mentioned that, right, is that to me, the thing that is like unique about this problem is that it is one aspect of a very large problem that will require a lot of work by many different people with many different skills. But here's like kind of one niche part of that problem where it is actually useful to have cryptography.
Interesting. Do you want to tell us a little bit more about what this TCN Coalition is and like what it's made up of?
At the Zcash Foundation, we wrote a blog post that was basically kind of a call to action for cryptographers should get involved with contact tracing protocol efforts. Through that, I got connected with Dana Lewis and Scott Lebrand, who had started a project several weeks earlier called COEPI, which stands for Community Epidemiology. And the idea of that project is basically like, rather than waiting for some kind of centralized response, people could have a way to altruistically just self-report symptoms to each other, as a kind of explicitly opt-in, just people sharing information. And they had been collaborating with another project called COVID Watch, which was also focused on the problem of doing contact tracing, albeit with a slightly different model, focusing on sort of like test results, reports from doctors, etc. And so they were working on a common protocol. I got involved with that. There were some really great design suggestions from George Dnes, and I kind of helped combine and streamline different design elements into a kind of proposal for a contact tracing scheme, obviously with many other people. Then this effort kind of started snowballing because there were all these other people who also, wanted to interoperate on having a common protocol. And so at that point, the kind of interoperable protocol layer was spun out into a new organization, by which I mean actually like a new Slack instance, called the TCN Coalition.
And is this group at all working with any governments, or is this plan to have it be a standalone? So you sort of mentioned it's opt-in, non-centralized, but would you still want to like connect with the larger governmental efforts?
I can't really speak for all of the projects that are involved. So that at the sort of level of this TCN coalition, the effort is making a common interoperable protocol for doing Bluetooth communication for contact tracing. And then there's different applications that are using it. And I believe that some of them are attempting to work with different governments. I'm not really You're
not working at that level.
Yeah, I have been just trying to sort of stay on top of what's been going on just with like Bluetooth level protocol stuff. Because in any project, there's now, I think, more than a dozen different groups that are kind of joining up with this effort. And in any kind of project that starts snowballing, as the size grows, you sort of have to kind of pick like, okay, here are the things that I am able to pay attention to
deal with.
So I've been trying to focus on the protocol stuff.
I mean, I do think we have a few guests line, or kind of I'm in talks with a few upcoming guests where we're going to explore some of these topics a little deeper, probably on the different levels. But I think for the TCN Coalition, from what I understand, it's really just focused on coming up with a standard of sorts. What is it? What does it look like? Like what, I mean, I know it's not built yet, but like, what are you even playing with? What kind of cryptography?
So the cryptography is very simple. The cryptography and Bluetooth part, to some extent, is already either built or on its way to being built. The basic kind of shape of this protocol, you can think of as being a kind of a weird type of messaging app where you go around and you are carrying a device that does Bluetooth, and it broadcasts pseudo-random numbers called temporary contact numbers.
Thus TCN, I guess.
Right. While doing so, it also observes all the numbers that it receives over the radio. And at some later point, as a user, you can send a message to all of the people who you were in broadcast range to, containing some data. And when you do that, you actually prove that you were the one who generated all of those numbers. And different applications can have different policies for basically authentication of those messages. So, for instance, an application like Coepi that is trying to focus on people doing symptom reporting has a kind of a different trust model than an application that is focused on test results that are in some way verified. But that's kind of like an application level concern. At the core protocol, it's kind of agnostic to what that decision is.
How can I send a message to the people I've been in touch with without there being like a centralized register of these are the people that exist and I don't know what their IP is or what their, who relays the message?
So you do need a centralized relay. but the relay does not need to be trusted. And the relay learns nothing about the kind of social graph of interactions between people. So effectively, the way that the protocol works at a kind of a abstract level is you break up your history into chunks, as you're moving around in the world, right? Every so often you sort of start a new chunk. And in that chunk, there's basically a ratcheting procedure that lets you derive an arbitrary number of these temporary contact numbers. Later, when you want to send a report to people who you may have come in contact with, you upload to the relay server some data that is sort of like a pre-image of some chain of hashes that allows anyone to download your report and kind of regenerate all of the temporary contact numbers that it is related to and compare those against the local observations. So because the server only ever sees, here are reported numbers, it doesn't learn anything about the social graph of the users.
I see. And you can sort of prevent learning metadata by observing the relay server because basically everyone downloads every report and tries to see if it's relevant to them.
So the way that works on the back end is that you would quantize time into fixed blocks, like say 6 hours. And for every time interval, the server will accept, all the incoming reports. And then when that interval ends, it takes the batch of all the reports that it got, it randomizes the order to prevent someone from saying like, oh, well, if these two reports are next to each other, then they're more likely to be like different chunks of the same user's history or something like that. And once it does that, it's got like basically a very compact static file that can be put up on a CDN or something. So there's very little server load, although there's bandwidth use because all clients download all messages. You don't have a problem of having a ton of compute heavy server work. It's very cacheable.
How close are you to kind of finalizing this proposal? Do you think you're talking like weeks or months? Is there a timeline or a goal?
It's very difficult to make a prediction because the contact tracing ecosystem is in flux. I would say that there are a number of teams that are currently working on integrating the protocol into the current revision of the protocol into their application. And we are currently working on planning the next iteration of the protocol version. It would be great if there were compatibility between, so TCN is not the only proposal for doing decentralized contact tracing. And it would be great to try to achieve compatibility or sort of combination of designs. And there's discussions about that ongoing. And of course, Apple and Google announced, their own entry. And so, obviously they have like a very large install base. And on the iOS side in particular, they have access to kind of the like platform Bluetooth internals. But it remains to be seen like exactly what the final version of that design will be or what that will actually look like.
And how private that actually ends up being.
I mean, I would say that although there's like a lot of kind of reflexive skepticism of Google and Apple, in this instance, I think that the protocol that they published is relatively good. Like there are a few things that I think, I personally think could be different. But if that was the thing that ended up being deployed, I would be very happy relative to the alternative of, some government mandates that everybody report their GPS locations. I do think that the AG protocol is pretty privacy preserving. And,
that's good to hear.
The privacy team at Apple does actually care about user privacy. Also, there are many people at Google who care. So in this case, I think that those people were successful.
I think that would actually be interesting to talk to somebody from one of those teams to find out about what they're planning. I don't know if they'd come on our show, but
yeah, it is an interesting space and a scary space. I mean, one part of me goes, if Apple forces me to have contact tracing, I'll break my phone in half and go back to the Stone Age. And part of me is like, well, I don't know, whatever.
I think you just encapsulated everybody's attitude very well there.
Yeah.
Well, one thing that I think may not have been made totally clear in reporting on it is that in their protocol, it is essentially indistinguishable from just normal having Bluetooth enabled up until the point at which someone reports that they tested positive or something. And so the question is not whether like Apple would force you to use the app. I think that the question is whether some health authority would force people to use the system to send reports. And I think that would be very bad. I think that these systems should always be opt-in. One of the problems that's very difficult to solve for kind of fundamental reasons is the problem of reporter privacy. So anytime you have a decentralized contact tracing system, at a minimum, it's possible for someone, it's always possible to come up with a scenario where someone could infer the identity of the person who is reporting just based on circumstance. Like if you met with one person during, Wednesday the 27th, and then later you like get an alert on your phone that says like on Wednesday the 27th, you may have been exposed, then like, anonymity set of 1, right? That's one variant of the problem. Another is if you go to a place like London where all of the garbage cans have Bluetooth antennas and try to like track everyone's movements through Bluetooth, then effectively, all of those garbage cans are also could be, quote, users of the system who want to like know whether they were exposed. And so there's a sort of a fundamental problem there, which is that if you are trying to tell other people who you came in contact with that they may be at risk, that's information that they'll learn. And that information may be possible to combine with other information. And so it should be your choice to decide whether or not you want to do that.
I think the natural fear here is not the application at hand, but like the scope creep that can happen. When every device in the world has this installed, the government suddenly goes, well, we need to enable this for everyone because we want to stop terrorists. You don't like terrorists, do you? No. So you need to tell us when you're in touch with a terrorist. And then it's, well, you need to tell us when you're in touch with a pedophile. You don't like pedophiles, do you? And then, you need to tell us when you're in touch with a drug dealer. And like, it just goes on. And yeah.
So I think that it's a good concern, but there's a way to address that concern, which is to build a system whose design is structured in a way that kind of prevents scope creep. And so for the TCN proposal with the Apple Google protocol, with the DP3T protocol, all of these are based on people pushing messages to other people that they may have come in contact with. And so all of the examples that you mentioned of scope, I'm not saying that no scope creep is possible, but in particular, the sort of potential scope creeps that you mentioned wouldn't really be possible to retrofit into this system because nobody can learn who they came in contact with until that other person publishes a report.
So it would have to be the drug dealer saying, I'm a drug dealer, and then everybody would find out that they'd come in contact with a drug dealer.
Right. And so that doesn't really I mean,
maybe drug dealers want that, but
I'm sure that there's ways to like make horrible laws that would misuse the system, but the really obvious baseline ones, I think aren't sort of functionally compatible.
Well, that's somewhat reassuring. But there's also no shortage of horrible laws. So I don't know. But it's I think it's been interesting following, because there's a healthy amount of criticism, but there's also like a lot of people that come out and defend the systems that even like I saw someone come out and defend Apple on like, no, like these engineers know what they're doing. They've thought about this or that thing, and like it seems like a reasonable system to build.
I've even heard, I mean, in the last interview I did with Claudia Diaz last week, what she mentioned she had almost an optimism about what's possible for privacy tech today versus what she had seen during sort of post 9/11 fighting terrorism level of surveillance. This, today just feels like a lot more helpful towards people. Like the goal is to actually, help people not get sick. The goal is not to like find out who has bad ideas in their heads. And that lack of confrontational approach could maybe offer some opportunity. I mean, we don't know, but I thought that was like a nice way of thinking about it.
Yeah.
All right. So we've talked about a bunch of things, and it's been very interesting. We've gone from crypto libraries into Zcash into TCN and a bunch of things in between. It's been great having you on. So thank you very much.
Well, it's been really great to talk with you. Thanks for having me.
And to our listeners, thanks for listening.
Thanks for listening.